Alright guys, so today what we're going to look at is 8.2, which is multiplying, dividing, and simplifying roots. The first thing I want to kind of go over with you really quickly before we get going is in 8.1 we talked about if we took the square root of x to the fourth, that would be x squared, because all you do is you take this even root and you divide the two. But what I want to show you really quickly is, let's say that instead of having an even exponent, let's say that you had an odd exponent. So if I go 7 divided by 2, I'm going to get 3.5. So that doesn't work for us. So what we have to do is we literally have to break it up just a little bit. So what we would do is we would subtract 1 from this, so we'd have y to the 6, but then we also have to multiply it by y, or y to the first power, because when you're multiplying with multiplying exponents with the same base, you add their exponents. So 6 plus 1 will give us 7. And then to pull it out, we would go 6 divided by 2, so that would be y to the third square root y. Okay, so let me show you another one. So whenever you have like x to the 11th, and you're trying to take the square root of that, if I go 11 divided by 2, I'm going to get 5.5, so that doesn't work. So what we have to do is we have to break it up. So we subtract 1 from that, so that would be x to the 10th times x, because 1 plus 10 will give me 11. And then we can pull this x to the 10th out by dividing it by 2, or taking 10 and dividing by 2, so this would be x to the 5th square root x. We'll practice this a little bit more today, but I just want to get that in your back pocket as well. So, product rules for radicals. For non-negative real numbers a and b, you could do the square root of a times the square root of b equals the square root of a times b, so I mean you can multiply them together and then simplify. Or you can take the square root of a and b, and then you can separate the two. So you can do the square root of a times the square root of b. But this only works for multiplication, because remember, product means when you multiply. Okay? So what this means is there's two ways that you can approach problems like this. So if you have the square root of 4 times the square root of 9, what you can do first is you can clean up these rational numbers, or these perfect squares. And the square root of 4 is 2, and the square root of 9 is 3. And 2 times 3 will give me 6. Or the other way that you can approach it is you can multiply within the square roots. So you can go 4 times 9, and 4 times 9 is 36, and the square root of 36 is just 6. So either way can get you to the answer, and I don't care which way you choose as long as you show your work. Alright, so let's make this real. So if I have the square root of 3 times the square root of 5, well, the square root of 3, that's a prime number, so we're not going to be able to take, so it's a prime number, so we can't take the square root of it. And same thing for 5. So all we can do is combine the two. So we go 3 times 5, which is square root of 15. Okay? Now if I got the square root of 13 times the square root of x, same thing, I can't do anything with it, so I'm just going to go 13 times x is the square root of 13x. Now this one, I go the square root of 6 times the square root of 11. Neither one of those are perfect squares, so I could go 6 times 11, which 6 times 11 is 66. And then this last one, square root of 12 times the square root of 12. 12 and 12 are not square roots, but if I go 12 times 12, I get the square root of 144, which that is a perfect square, which would be 12. But remember, another way that you could approach this problem is you could go the square root of 12 parentheses squared, and remember, square roots and squares cancel each other out, which just leaves me with 12. Either way completely works. It's your decision. Just make sure you show work. Alright, so the next thing that we're going to do is we're going to simplify square roots. So using the square root of a times b equals square root of a times the square root of b, we're going to find we're going to find an a that is a perfect square. Okay, so what we're going to do is we're going to identify our perfect squares. I would highly suggest before you start this homework assignment that you write your perfect squares like up in the top margin. So to find the perfect squares, what you do is you just would use your calculator, and you can go 1, and then you could do an up arrow 2, or you could go 1 times 1, which is 1, 2 times 2, which is 4, 3 times 3, which is 9, 4 times 4, which is 16, 5 times 5, which is 25, 6 times 6, 36, 7 times 7, 49, 8 times 8, 64, 9 times 9, 81, and 10 times 10, which is 100. So what this means is these are all numbers that you're going to be looking for underneath the square root. And once you find them, you can pull it out to know the perfect square. So for example, if I have the square root of 64, then I know that that automatically is going to be 8. This is kind of a shortcut for you to be able to pull it out, which I'll show you what I mean in just one second. So yeah, let me go to the next slide. So to make it real, we're going to use the square root of a times b equals the square root of a times the square root of b. And you always want to pick the largest perfect square. Okay? So if I look at the square root of 60, when I look at the square root of 60, it's not a perfect square, which is a-okay. So what I'll need to do, just like we did in chapter 6, is we're going to need to find our factors of 60. So remember, you use your calculator to do this. The first factor of 60 is 1 in 60. The second factor would be 2. So if you go 60 divided by 2, you're going to get 30. 60 divided by 3, you're going to get 20. 60 divided by 4, you're going to get 15. And then 60 divided by 5, you're going to get 12. And 60 divided by 6, you're going to get 10. Okay? And these are all your factors. Remember, the way that you run out of them is, so if I do 60 divided by 7, that's not going to go in evenly. 60 divided by 8, that's not going to go in evenly. 60 divided by 9 will not go in evenly. But 60 divided by 10 will give me 6, and that's how I know I've exhausted them all. So what I'm doing is I'm trying to look for my largest perfect square. So I'm trying to look for these numbers right here in purple, but I'm trying to look for my biggest one. So I definitely see the 4, and that is all the perfect squares that I have. Now it could be in this column or this column, it doesn't matter which. So what I do now after I find my perfect square is I rewrite the problem, and I always put my perfect square, which is my a, first. So I'm going to go 4 times 15, because what I've got to do with that perfect square is I've got to pull it out. And the square root of 4 is going to be 2, and then what's left underneath the square root is the 15. And this is as simplified as it can be. Okay, so I don't want you to plug it into your calculator and just tell me 3 places pass, because this would be an irrational number. I want you to find the factors, pull out the perfect square to simplify. Okay, so let's try this next one. So I got the square root of 75. Well, 75 is not a perfect square, so what I need to do first is I need to find my factors of 75. So this would be 1 and 75, 2 doesn't work, 3 and 25, 4 wouldn't work, and then 5 and 15. Okay, so if I look at these, I'm trying to look for a perfect square again. So I'm trying to look for a perfect square, so that wouldn't work. The 3 and 25 would work because 25 is a perfect square, so it doesn't matter which side that you see it as long as you can find the perfect square, and that would be my largest. So I take the square root of 25 times 3, and the square root of 25 is going to be 5 square root 3, because that's what's left over, and I box my answer. Okay, so pause it and try to see if you can do C. Remember, you're looking for your largest perfect square. Alright, so first thing I see that it is not a perfect square, so I have to find my factors of 500. So that would be 1 and 500, 2 and 250, 4 and 125, 5 and 100, 10 and 50, and 20 and 25. Okay, so I've got 4 as a perfect square, I've got 25 as a perfect square, and I also have 100 as a perfect square. My largest one is 100, so this is the one that I'm going to use. So I take the square root of 100 times 5, which the square root of 100 is going to be 10 square root 5. Okay, now I want to do one more problem. This is going to be called the challenge problem because you're going to see some of these on your homework. So we're going to do 24x to the 7th. Okay, so the first thing that I look at is 24 is not a perfect square, so I need to find the factors of 24. So 24 is 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Okay, my largest perfect square is going to be the 4, so I'm going to use the 4 and the 6. So I've got 4 times 6. Now I have x to the 7th. So if I go 7 divided by 2, that's not going to go in evenly. So like I showed you on the first slide today, what you got to do is you got to break it up. So this would be x and then subtract 1, so x to the 6 times x. So now there's two things that we can pull out of the square root. We can pull out the square root of 4, which is 2. And we can pull out this x to the 6 because 6 divided by 2 is going to be x to the 3rd. And what will be left over with inside the square root is 6x. So this is definitely a challenge problem, but you're going to see problems like this on your test and on your homework. Okay, so these are perfect squares. Now what we're going to do is we're going to simplify cube roots. So to simplify square roots, you look for the perfect square. To simplify cube roots, you look for the perfect cube. Okay, so instead of perfect squares, we're looking for perfect cubes. And the way that you know this is you're going to see that 3. Okay, so let's write out these perfect cubes. I definitely don't have them memorized, so I don't expect you to, but you can use your calculator and remember, write them at the margin of your sheet before you start your homework. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. 6 times 6 times 6 is 216. 7 times 7 times 7 is 343. 8 times 8 times 8 is 512. 9 times 9 times 9 is 729. And 10 times 10 times 10 is 1000. Okay? So now, instead of looking for perfect squares, what we're going to look for is perfect cubes. And the way that you know that it's a perfect cube instead of a perfect square is because you see the cube root. Alright, so we're going to take the cube root of 24. So 24 is not a perfect cube, and the way that I know that is I look at my perfect cubes and I don't see 24. So what that means is I have to find my factors of 24. So 1 and 24, 2 and 12, 3 and 8, and then 4 and 6. So this time I'm looking for my perfect cube. So I'm looking for these numbers in purple. And the only one that I have is the 3 and 8. Again, you want to make sure you do the largest perfect cube because then that's a little bit less work. Okay, so how I would write it is I would go the cube root, I would write my perfect cube first, times 3. When I pull out the cube root of 8, that's going to be 2, and then cube root 3. And that's that answer. Okay? So now what I want us to do is I want to do the cube root of 250. So what I want to do is I want to find the factors of 250. So 1 and 250, 2 and 125, 5 and 50, and then 10 and 25. Okay, so again, I'm going to look at my list for the perfect cubes. So I'm trying to look for my perfect cube. That doesn't work. 2 and 25, that one could potentially work. 5 and 50 doesn't work, and 10 and 25 doesn't work. Because remember, I'm looking for my perfect cube. So the 2 and 25 absolutely works, so I take the cube root of 125 times 2. And when I pull that out, the cube root of 125 is going to be 5, so I got 5 cube root 2 as my final answer. Okay? Now let's try this last one together. So I got the cube root of 1 over 125. Well, we know 1 and 125 are perfect cubes, so what we can do is we can actually split these up. I don't want you to be intimidated by fractions. Just split it up. Okay, and the cube root of 1 is going to be 1, and the cube root of 125, what we just found, is going to be 5. And that's as far as you have to take it. Okay? The next thing that we have to do is we have to multiply and simplify. Okay, so there's a couple techniques to do this, and I'm going to show you both ways. Going back to the first slide. So what you can do first, and I think this is a little bit easier, is you can multiply inside and then simplify. So if I go the square root of 10 times the square root of 50, that would be 10 times 50 is going to be 500. Okay, and then I can find my factors of 500, which are 1 and 500, 2 and 250, 4 and 125, 5 and 100, 10 and 50, and 20 and 25. Okay, remember I'm looking for my largest perfect cube. Yeah, 25, 4, and 100 are all perfect, perfect squares. I'm looking for my largest perfect square. So 4, 100, and 25 are, but 100 is my largest, so I take the square root of 100 times 5, and then when I take the square root of 100, it would be 10 square root 5. This is one technique, and this completely works. Alright, so another way that you can approach this problem is you can simplify these square roots, and then you can multiply them. So if I find the factors of 10, that would be 1 and 10 and 2 and 5. None of them are perfect squares, so I need to just carry down the square root of 10. Then I find my factors of 50, so that would be 1 and 50, 2 and 25, and then 5 and 10. 25 is a perfect square, so I could take the square root of 25 times 2. So when I clean that up, that would be the square root of 10 times 5 square root 2. Then I would multiply them together. So this is like 1 times 5, so that would just be 5. 10 times 2, which would be 20. Then I find the factors of 20. So that'd be 1 and 20, 2 and 10, or 4 and 5. 4 and 5 is what I would use. So I'd go 5 square root 4 times 5. Then I would pull out that 4, so the square root of 4 is going to be 2, so 5 times 2 square root 5. And the last thing I do, 5 times 2 is going to be 10 square root 5. So I get the exact same answer, it's just kind of up to you which way that you want to take it. I think what's in purple is a little bit easier, but it's up to you. You're going to be dealing with larger numbers. If you don't want to deal with larger numbers, then use this second technique. And I definitely suggest to practice both ways. Okay, so the square root of 8 times the square root of 12. What I'm going to do is I'm going to do it the purple way. So I'm going to take, I'm going to multiply 8 times 12, which would give me 96. Next thing I'm going to do is I'm going to find my factors of 96. So 1 and 96, 2 and 48, 3 and 32, 4 and 24, 6 and 16, and 8 and 12. Okay, looking for my perfect squares again. I know that 16 is a perfect square, 4 is a perfect square. Do I have any others? Nope. My largest perfect square is going to be the 16, so that's the one that I'm going to use. So I'm going to do the square root of 16 times 6. And the square root of 16 is going to be 4. So I'm pulling out a 4, square root of 6. And that's my answer. Now, we have to deal with the quotient rule. Now, the quotient rule for radicals is really just talking about division. Because whenever you see quotient, what you're really doing is you're dividing. So if A and B are non-negative real numbers, and B does not equal 0, because if B equals 0, like in chapter 7, that means it's going to be undefined, then the square root of A over B equals the square root of A over the square root of B, and the square root of A over the square root of B equals the square root of A over B. Okay? So, there's a couple ways to approach this that I think make it pretty easy. Simplify as much as you possibly can. So, I got the square root of 4 over 49. What I noticed about 4 and 49 is that they're perfect squares. Okay, so what I can literally do is I can break it up. I can go the square root of 4 over the square root of 49. And we know the square root of 4 is going to be 2. And the square root of 49 is going to be 7. And that cleans it up. Okay, so it looks intimidating at first because, oh gosh, it's a fraction. But break it up, clean it up. Alright, now if it looks like this, we get the square root of 50 over the square root of 10. Okay, well I know 50 and 10, I can divide those two and get something evenly. So what I'm going to do is I'm going to put them together. So I'm going to go 50 divided by 10, because 50 divided by 10 is just going to leave me with the square root of 5. In the past, I've seen on some of the tests, I have a problem that's like this, and people try to find the factors of it and then simplify it, but make it easier on yourself. make sure you read the problem first to see, hey, can I do this easier? And if you combine these two together, that's a lot easier. Okay, so now what we're going to do is we are going to be using the product rule and the quotient rule together. So I've got 27 square root 15 over 9 square root 3. Alright, so what I'm going to do is I'm going to deal with my whole numbers separately. So 27 times the square root of 15, and then I'm going to go 9 times the square root of 3. Because I know 27 divided by 9 is going to leave me with 3, and then I'm going to put these together like the second example. So 15 divided by 3. So I would be left with 3. Square root 15 divided by 3 is 5. So super intimidating problem at first, but if you split it up into what the product rule is, and then clean it up, you should be good to go. Alright, now here's the last problem. So we've got the square root of 3 over the square root of 2 times the square root of 8 over the square root of 27. Now 3 and 2 will not simplify, and neither will 8 and 27. So what this means is I need to multiply straight across. So 8 times 3 would be the square root of 24. And 2 times 27 would be the square root of 54. Okay? Now, once I look at it like this, I can find my factors of 24, and I can find my factors of 54 quite easily. So my factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. My largest perfect square is going to be the 4 and 6. So I take the square root of 4 times 6. And the square root of 4 is going to be 2. Square root 6. Then I got 54, so that's 1 and 54. 2 and 27. 3 and 18. And then 6 and 9. So my largest perfect square here is going to be the 6 and the 9. So the 9 is the perfect square. So I do the square root of 9 times 6. And when I take the square root of 9, I'm going to get 3 square root 6. And just like we did before with simplifying, anything over itself cancels out. So this cancels out, and I'm just left with 2 over 3. So super intimidating problem at first, but once I clean it up, you should be good to go. Alright guys, so what I need you to do now is I need you to do the 8.2 homework. Please make sure that you show all work, and when you come to class, make sure that you got some questions for me. Thank you.